Deep below the surface of the ocean surrounding southern Tasmania, an invasion is taking place. They inhibit vegetation growth, destroy natural ecosystems, leaving areas barren wasteland. The highly invasive long-spined sea urchin presents a significant issue towards Tasmanians' marine biodiversity. To combat this, local industries are harvesting the sea urchins for global sales. This, however, creates another major ecological problem, generating 500 tonnes of waste yearly. Additionally, these companies individually spend roughly up to 20 grand a year disposing these waste. That 20 grand could be redistributed in the economy if only there was a more sustainable use for this material. Raising the question, how might we repurpose this waste stream to benefit human and non-human stakeholders?
Sea urchin shells are composed of approximately 90% calcium carbonate, a widely used compound across various industries, including ceramics. That is why this project's aim is to create a functional and sustainable alternative to typical ceramic waterproof tiles. The tile production process begins with the refinement of the cleaned and dried sea urchin shells into a fine powder. This step entails repeated crushing, blending, and sieving until even the biggest chunks no longer remain. A binding agent is created via heating gelatin in water, then adding agar. The shell powder combined with clay dust and the binding agent forms a basic solution. Borax and glycerol were then added to the solution, forming a solid structural paste. This paste is then poured into a mold, based on the hexagonal shape within the sea urchin's shell structure. This represents a principle of the regenerative design process, biomimicry. In essence, if this structure works for the urchins, it should work for household environments. After being left to set for 24 hours, the set composition was removed from the molds and baked at 100 degrees Celsius for 2 hours. Once cooled, a coating of linseed oil is applied with a brush. This hydrophobic coating prevents excessive moisture absorption, which in turn inhibits mold and fungal growth that usually occurs in household environments. Compared to typical bathroom tiles, deep sea tiles leverages the circular economy by being able to biodegrade at end of life, balancing sustainability with function.
Through comprehensive material testing and iteration, the material showed promising characteristics as a functional bathroom tile. Across our material tests, we explored several iterations, including adding casein, replacing borax with citric acid, and incorporating kaolin clay. Kaolin clay showed the most promise among the experiments, balancing structure with aesthetics. Currently, the finished tile's properties are quite promising. However, a key limitation would be the lack of equipment and resources accessible when creating the tiles.
Ideally, this product will be used more commonly in interior bathroom infrastructure, providing a regenerative alternative to the current industry standards. Furthermore, it would save thousands of dollars for the companies who are currently paying for waste disposal. When the tiles break or are no longer in use, they can be safely biodegraded, providing nutrients to the natural ecosystem. Reduction of the invasive sea urchin population, in turn restoring natural habitat and biodiversity. The removal of sea urchin waste in general and harmful landfill benefits both human and non-human environments.
From grey water to seawater, together we can restore biodiversity to our natural ecosystem.